Okay, guys, this is the second part of the chapter 5 notes. Again, pretty small section. This one is 5.3, which is elements and their oxides. Remember, an oxide is taking an element, whether it's sodium or hydrogen or sulfur or nitrogen, whatever, and combining it with oxygen. Now, some elements have multiple oxides. Carbon, for example, is carbon monoxide, carbon dioxide. We've got sulfur dioxide, sulfur trioxide. So there can be a few. What we're going to talk about though is how various oxides are going to, what they're going to form when we put them in aqueous solution, right? And remember, that means we're going to dissolve them in water and we're going to look at what happens from there. So what we are going to get is that some of the elements, oxides, are going to produce acids, and some of the elements are going to produce, their oxides are going to produce bases. So quick little review about acids and bases. First, if we didn't remember, so acids, right? All acids produce hydrogen ions in solution, and bases are going to produce hydroxide ions when in solution. So we take just a regular substance like sodium hydroxide, dissolve it in water, and it releases those hydroxide ions to be on their own. And the presence of hydroxide ions is what gives us a base. And when we talk about acids and bases, we have to remember one other thing, and that's our pH scale. Remember, pH stands for the power of hydrogen. That's why the H is capitalized, because it is the chemical symbol for the element hydrogen. This is what we've got. It goes from 0 to 14, and it makes sense mathematically that 7 is right in the middle. It is neutral. So things like water is the greatest example. Pure water is pH of 7.0, which is neutral. Anything that is below, I guess I should say 6.9999, but 1 to that 7 mark is going to be acidic, and anything over that, 7 to 14, is going to be basic. Now here's where it's a little bit different. You can't really think of the pH scale as a number line, because yes, 7 is in the middle, but that would mean that if we move 1 unit away, if we move forward, it gets stronger. It gets weak. As we go backward, it gets weaker. That's not the case. 7 is neutral in the middle. So every time we move away from 7, so if we move to 6, we have a weak acid. If we move to 5, it's a little stronger. 4 stronger, 3 stronger, and so on and so on and so on. Same thing with bases. 8 is, it's a little bit easier with the bases. 8 is a weak base. 9 is stronger. 10, 11, 12, 13, 14 until you get there. Okay? That part's hopefully something you remember from grade 10. So what we're going to look at is specific ones. So if we take a non-metal oxide, okay? Non-metal oxides, so remember that would be sulfur, nitrogen, carbon, any of those types. So we're going to take sulfur dioxide, SO2, which is a gas. Remember, we have to include states of matter in all of our chemical reactions now. We're going to add it to liquid water. So if we add these two things together, what type of reaction would this be? Synthesis reaction, because we're putting two things together to get one product. H2SO3. Okay, this is AQ is our state of matter because it's dissolved. It's a solution. This is actually called sulfurous acid. Okay, it's kind of like sulfuric, but it's sulfurous acid. Slightly different. Sulfuric acid would be SO4. Now, where we are here, this is not necessarily, we don't have any hydrogen ions, so we don't have an acid yet. But what happens is spontaneously we have what we call dissociation, where this H2SO3 breaks down in the presence of other water molecules. So one water molecule might do this and another one might interact with these that we formed. And that H2SO3 is breaking down into hydrogen ions and sulfite, as I remember correctly. Right? Sulfite ions, not sulfate, SO4, sulfite ions, and there's the presence of my hydrogen. And there's two of them, so this is a relatively strong acid, stronger than if, say, we only had the one there. But there's our two hydrogens. So non-metal oxides often take two reactions. First is some type of synthesis, and then a decomposition reaction afterwards in order to get those hydrogen ions. Okay? Our metal oxides, on the other hand, and you probably use sodium hydroxide in grade 9 and 10. It's the most common base that we use. It's a solid. It's a little white pellet. When we put it into hydrogen, It's been a long quarantine for me too. Sodium hydroxide white pellet into liquid water. Right away, what happens is that those sodium, remember this is ionic as well, right? This is ionic, this one is molecular. So ionically speaking, we're going to split those ions, the sodium and the hydroxide that make it up. Both now are AQ. And we still have water that's there. So water acts as the medium to split the sodium from the hydroxide in a chemical formula into from one compound breaking into its individual ions in solution. And the presence of these OH ions are what give it its basic properties. Okay, hopefully that makes some sense. I'm going to do kind of one more example where we have, similar to the first one, another pretty common crap, sorry. I want to make sure I do it correctly for you guys. CO2 is a gas plus H2O liquid. Okay. So we've got our CO2 gas, very, very common. We know it's carbon dioxide. Adding it to liquid water. Okay. Synthesis reaction, we're going to get H2CO3. So 2 H's, 1 C, 3 O's. This is AQ. Okay. This is actually called carbonic acid. Right? This is the acid that's in pop. Carbonic acid, if you look at the label on a can of Coke, carbonic acid is what's in pop. Now, we don't have the acidic properties yet. So what happens is now this is going to dissociate. We're going to start with that H2CO3 again, AQ. And we're going to split it into the 2 hydrogen ions, which are also AQ, plus CO3 negative 2 AQ as well. Right, so still balanced. So even when we're dealing with ions, we're balancing on the other side. Right, and this dissociation reaction now gives me, there's my hydrogen, which gives me my acidic properties. It'd be the same if I used a different type. And again, the way you can tell is you've got, right, non-metals are going to give you acids. Metals are going to, oxides are going to give you bases. Non-metal oxides are going to give you acids. Okay, so that is the gist of those two sections, which is all we're going to do in chapter 5. So I will do what I normally do. I'm going to put the 2 videos up first, and then I will put right after the notes, and inside each note at the end is the questions. If there are any questions that you do have about section 5.1 or section 5.3, just again put them on the Google Hangout, and I'll do just a quick whiteboard of that particular answer, and I'll just title it with whatever question it is. Okay, so hopefully that won't be an issue. This one's pretty simple. I'm also going to put up some quizzes, chapter 4 quiz and a chapter 5 quiz. Grade yourselves on it, and try and do it without the textbook, but grade yourselves on it and see where you are in terms of answers. Haven't really figured out exactly how I'm going to do tests and stuff yet, but or test your knowledge on some of these things, but we'll figure it out. So we're going to go on to do, after this, it's Unit 3. Super important as we go forward, but it's most importantly, you really got to know your nomenclature. You got to know your predicting products of chemical reactions and how to balance equations. And what type of reaction do you have? So stuff from chapter 4 and even back into chapters 2 and 3, essential to go forward. A lot of math and calculations going forward into chapter 6. So really important. If you're not real comfortable with what I just said in those topics, go back and revisit them, because otherwise it's going to not make a lot of sense and it's going to be way more difficult. Okay, good luck. And again, any questions, put them on the Google Hangout and we'll figure them out together. Thanks, bye.